Okay, so this is the lesson I would teach. It would be about properties of integrals or properties of antiderivatives. So what I would start off with is, I would start off with like just what are the properties given certain functions. So I would start off with order of integration. If you switch a and b to be b over a, you got to make it a negative. I would say that's important when you are thinking of flipping the area underneath the curve. Okay. I would then talk about 0. So when you have the same bound, let's say it's 2 and 2, a and a, that property would, or the area underneath the curve would always be 0. Okay. From there, what I would do is I would talk about constant multiples. So if you just have a number out front, let's say 3, you can essentially pull that number out front, and it doesn't have to be integrated into the f of x function. And then also same thing with a negative. You can pull that out front. So say it's like a -2 or a -1. You can do the same thing as that. Okay. For sum and difference, I would say you can split the integral into 2 parts. So f of x being the first part, plus or minus, depending on whether or not it was adding or subtracting, the g of x function. That makes it a little easier to integrate. Then for there, I would do like additivity, which is if you have from a to b, let's say you have a value c, or I'm sorry, yeah, from a to b, and then from b to c, it's the same thing from a to c. That's the same thing as like transitive property. You take out the middle guy. And then finally the constant. When you have a constant, you would just do like k, and then you can just do like b minus a in parentheses. So then I would go into some examples. Okay, so suppose you have the following 3 objects. Okay, find each integral. Well, the first one I notice is from 2 to 2, which means that it's the same bound on top and bottom, which means it's always 0. You're using that 0 property. Okay. For this one, I would say, okay, it's from 1 to 5. Which one looks like we have like 5 and 1 integrated, and that's going to be this one. So what I can do is I can basically flip the 2 terms, so it becomes 1 and 5, and you want to add a negative. If this is a positive 8, then this would be a negative 8. Okay. For this one, I would say the 3 can be taken out front, so it would be 3 times from 2 to 1 f of x, which is -4, so then that would be -12. Okay. And then finally from this one, f of x from 2 to 5, okay, well I would say from 2 to 1, or 1 to 2, it's -4, and from 1 to 5, it's 6. So I would say, okay, you're just basically subtracting the 2, which would be like that, you get 2. Okay. So I would just do a little more examples with that, which is with numbers 2 and also 3. Okay. I would then move to like talking about like what do I do when I have a graph such as this where I have certain areas underneath a function. Okay, I would basically start with saying, okay, if you have like certain areas, you have kind of 3 different shapes going on here. You have a triangle here. Okay, underneath here you would have a semicircle. Okay. And then finally here, if we stop there, that would also be a triangle. So we can use those area formulas of triangles, semicircles to help us out. Okay. So I would basically start with this, okay. For letter A, I would start with from 0 to 2. That's basically from here to there. That's a quarter of a circle. So the radius is 1, okay. A quarter of a circle to find the area would be 1/4 pi r squared. If the radius is going to be the radius is 2. If the radius is 2, you would do 1/4 times pi times r squared, and I would say to leave it in terms of pi. So 2 squared is 4. Take 1/4 of that, you're just left with 1 pi. Okay. I would try one where we have like certain values added. So like I would try e. Okay. So e says from -4 to 6. Okay, well, that's the entire part. So that's all the way from here to there. So we would need to figure out, okay, the area of the full graph, okay? And notice how I would point out to my students that it has an absolute value. That means you're not taking negative areas. So that's another point I would take out. Yeah. Okay. So I would do a couple of those just dealing with that, and I would end with F, saying, okay, from -4 to 6, I could say, well, basically we found from E, the entire area underneath, I could just add that 2 and then do B minus A because I have to integrate 2 as well. Okay. For number 6, it says the graph of F consists of a line segment and semicircles as shown in the figure above. So it says evaluate the figure below. Okay. So what we're going to do is it says evaluate from 1 to 7, which means I'm starting here and I'm ending here. I'm basically breaking it down because now what I have is I can see I have a rectangle. I can see I have like a triangle up here and another rectangle, and then this over here is going to be a trapezoid. So basically, to find the area, okay, I'm just going to set this up. Basically, you want to find the area of the trapezoid using that formula, plus you're going to find the area of the triangle on top, plus the area of the rectangle, plus the area of another rectangle to find the area. So I would just talk about like how do you do that using certain shapes. For part B, it says find the average value of f of x on the interval 1 to 7. So average value, okay, would remember be 1 over b minus a. The kids will learn this. Integrate it from a to b of f of x. So I basically say take your answer from part A, add that 1 minus b over a, so it'd be like 1 over 7 minus 1, which is 1/6, and that would determine average value. And then for part C, I would finally connect all the dots together. So it says determine the answers to A and B if the graph of the F is translated 2 units upward. So I would basically say, okay, if we're talking about moving this graph 2 units upward, that changes the distance from the x-axis. Okay? I would talk about, like, in Algebra 2, they learned about translations, specifically vertical translations. What would happen with your function? Well, what would happen is you would have from 1 to 7 f of x, okay? But since you're moving 2 up, it changes the area underneath the curve. So I would add 2 to that f of x function and then integrate from there. Okay? So, of course, I would do these all if I was like teaching this actually, but just the setup is what I would start with. Alright, and then finally number 7, okay, this would be from like an AP test. So if I was teaching calculus BC at the high school level, I would want to make sure I have like something that like talks about like what would the AP test look like. So it says given this table, it says let f be a function that is twice differentiable for all real numbers. The table above gives values of x for selected points on the closed interval from 2 to 13. So remember, closed interval means that you are restricted to those values. Okay. So then I would talk about like what's the relationship between the derivative and the antiderivative. Well, if I take the derivative of an antiderivative, it essentially goes away. I'm just left with the function itself. So it says estimate f prime of 4, show your work to lead to your answer, okay? So what I would say is remember, okay, when we're talking about derivative, we're talking about the slope, okay? So to find the derivative, okay, I would do like something like this. I would pick 2 values and I would subtract f of 4, let's say minus f of 2 over the same x values, 4 minus 2. And so that would be f of 4. I'm sorry, back up. I was getting confused with that. So if I was trying to like estimate f of 4, I would do f of 5 minus f of 3. That would give me a good indication. And then do 5 minus 3 on the bottom. Okay. So f of 5 is -2, f of 3 is 4 divided by 2, and so you would get -6 over 2, which is -3. So I estimate it to be like that. So I would keep going on talking about like maybe using Riemann sums to kind of solve this, and then finally I would lead off with like maybe using a secant line and a tangent line to graph the following function. This would be their challenge problem. Okay. But overall, I think this lesson like kind of starts with the basics and like kind of morphs into whatever you need for them to see on the AP test. So that's why I chose this lesson. You can apply it to many different things as it pertains to antiderivatives. But yeah, that's it. Thank you.